Alright, for this tutorial we're going to be revising how to solve trig equations. Before we're going to look at any trig equations, we just need to familiarise ourselves with the CAST diagram. So you've got C-A-S-T. In this one, sine, cosine and tan are all positive. This one, only sine is positive. So that's where sine is positive. That also means that's where tan and cosine are negative. Tan is positive and cos is positive. So we've got our 4 different quadrants. It starts at 0 and goes round in a circle, so that would be 90 degrees, 180 degrees, 270 and back to 360. I've just written in 0, 360 and 180 because those are the ones we need the most for this. So A, finding out where they are all positive, that's what your calculator is going to give you. So finding out this angle is how we get that from the calculator. Finding this angle, where sine is positive, or the one where tan and cosine are negative, we do 180, so we're starting from there, minus the angle that we found in A. So 180 minus the angle that we found with the calculator. So tan is 180 plus, that's where tan is positive or sine or cosine are negative, but if you're trying to find something in this quadrant, it's 180 plus the angle. And finally here, if you need to find the angle, it's 360 minus. So if you're not totally familiar with that, it will become more relevant once we've done a few of the questions. The first question we're going to look at is 2 tan x minus 1 equals 0. So we're trying to solve this equation. We're trying to get solutions for x. Right now, we've got a few things attached to the tan x which we want to move over. So we want to first of all move over that minus 1. We're going to add 1 to both sides so that we have 2 tan x equals 1. And then we want tan x by itself, so we need to divide both sides by 2. So tan x equals 1/2. Now, once you've got to the point where you have tan x equals something, or sin x or cos x, whichever one you're looking for, that's when you can draw the CAST diagram. Once you've got tan x by itself, we draw our diagram. And we're going to decide which 2 quadrants that our solutions are going to lie in. Tan x is positive, because 1/2 is positive, so that means it's going to lie in this one, A, where all of them are positive, and it's going to lie in the one where tan is positive as well, this one down here. So we've got 2 different solutions that we're going to get, one in this quadrant and one here. First thing we have to do is get our calculator solution by doing inverse tan of 1/2. So you get your calculator, shift tan 1/2 equals, and so we have x equals 26.6 degrees. We're going to round it up to 6 degrees. And your other solution, and, so we've got our calculator one, which means we've got this one here. We now need to find the one that lies here. When we look back to this, we know that to find one that's here, we do 180 plus the angle that we found with the calculator. So, and 180 plus 26.6. So our 2 solutions are 26.6 degrees and 206.6 degrees. So we've got our 2 solutions, and that's you finished. Right, let's look at a different one now. This one I'm going to look at 3 sin x minus 2 equals 0. So we've not got sin x by itself right now, so we're going to start by adding 2 to both sides. 3 sin x equals 2. And to get sin x by itself, divide by 3. Sin x equals 2/3. Okay, we've got to the point where we have sin x equals a number, so we're going to draw our CAST diagram. Sin x is positive, so that means it's going to be in the one where all is positive and where sine is positive. So these are the 2 places where our solutions are going to lie. So first thing we do is find our calculator solution by doing inverse sine 2/3. So we have shift sine 2/3. And our solution here, we're going to round to 41.8 degrees. And don't forget, you're always going to have two solutions. It's going to be in this quadrant, which is where we do 180 minus 41.8 degrees. So 41.8 and 138.2. And those are your two solutions. Okay, I'm going to do two more. We're going to look at one where it isn't going to be positive. So we've got 5 cos x plus 2 equals 0. So we're going to take 2 off both sides. 5 cos x equals negative 2. So cos x equals negative 2 over 5. We've got to the point where we have cos x equals our number here. So we draw our cast diagram. This time cos is negative. So that means it's not going to lie here because that's where they're all positive or they're all negative. So it's not that one. Sorry, that's where they're all positive. So it's not in that one. It is in this one because that's where sine is positive, but cos is going to be negative there. This is where tan is positive, which means cos is going to be negative there, but it's not in this one because this is where cos is positive. So we have our two solutions going to lie in these two quadrants. Now, we can't find these two unless we find the one that lies here, the one that we found with a calculator. And this is where they're all positive, so we need to find, first of all, inverse cos of 2 over 5, positive 2 over 5. Because that's going to give you your positive one here, this, that we can then use to find it in these two solutions. So, what does that equal? Inverse cos 2 over 5. So that's 66.4 degrees. So that we just needed to do to get our other solutions. So our actual solutions, x is going to equal, first of all, it's going to be 180 minus that one where we've got s, that's 180 minus 66.4, and 180 plus 66.4. So our two solutions this time are 113.6 degrees and 246.4. Oh, sorry. And those are your two solutions. Right, I'm going to do one more. Get my piece of paper. The last one I'm going to do is 7 sin x plus 3 equals 0. So first of all, rearranging to sin x equals something. Take 3 off both sides. 7 sin x equals negative 3. Divide by 7 on both sides. Sin x equals negative 3 over 7. We've got sin x equals something, so we can draw our cast diagram. Sin x is negative, which means it's going to lie in t and c. So the opposite to what it would if it was positive. Before we can find t and c, we have to find this one that lies here, the one that's with the calculator, the positive version. So where it's all positive, we need to find that one first. So inverse sine of positive 3 over 7 will give us that solution. Inverse sine 3 over 7. 25.4 degrees for that one. But again, this is only so that we can get our real solutions. So first of all, we've got one that lies in this quadrant, which remember is 180 plus 25.4 degrees. And we haven't used this one yet. If you have to find it in this quadrant, going back to what we originally said, this is 360 degrees minus 25.4. And we have our two solutions. 180 plus 25.4, 205.4 degrees. Should probably be doing that in my head. And 360 minus 25.4, 334.6 degrees. And those are your two solutions. And that's you ready to solve these sort of trig equations in the exam. So you can have a look, maybe try some of the ones at the end of this video to run the practice questions, or you can look at some trig equations that are from past papers.